All right, good morning, everybody. Welcome to this third day of Stormwater Awareness Week, and we have a great workshop for you this morning. And this is Holly Terry with Sustainable Runoff Solutions. And Holly, why don't you tell us a little bit about yourself, your company, and then the hour is all yours.
Thank you so much, John, and thank you all for joining. I'm Holly Terry from Sustainable Runoff Solutions. We're in Colorado, mostly doing post-construction stormwater maintenance. And the presentation here today is routine maintenance always saves money, how to be proactive. So here is the agenda for our next hour together. We'll start with getting on the same page, speaking the same language by reviewing our condition scoring criteria. And then we'll go through 4 case studies that illustrate the ways that a post-construction lens can save long-term costs. We'll look at a PICP case study comparing 2 scenarios, a never-ending detention pond restoration case study, 3 profiles of designing with the end in mind, and a kind of a model stormwater steward with the last case study, the organized assets multifamily. And there will be time for questions at the end, but we also have Jason Terry in the chat, our engineer and founder, who can answer questions as we're going, so you don't have to hold them. And then if there's a theme or a question we want to cover in between the case studies, we can do that. There we go. So the goal here is to consider all elements of stormwater management through a post-construction maintenance lens, because considering the end use and how to keep the asset functional in the long run is the right lens through the whole process. It highlights everywhere that costly mistakes can be avoided. The driving principle here is prevention. We're trying to design, build, operate, and maintain assets with the idea of easy, routine maintenance to prevent restoration as much as possible, and restoring assets as soon as it's necessary to prevent the need to reconstruct the asset completely. I don't know why it's going backwards instead of forwards. There we go. Throughout the presentation, the agenda will be at the bottom as a progress bar. And we'll start with our condition score criteria as a way of framing the whole conversation and speaking the same language. Horizontal assets like pavements, ponds, and pipes that serve a property can be assigned a condition score at any point in its lifespan, and each asset has a service life. And left alone, each asset's condition will degrade over time. When the asset is new, the operator can make a decision to invest in routine inspection and maintenance as the most cost-effective way to keep assets functional and compliant. These systems have water quality functions, and municipal enforcers will be by at some point to inspect them. Over time, the asset condition bumps over a threshold where it cannot be made functional and compliant with routine maintenance and needs more complex, more expensive restorative maintenance. You can delay the need for restoration with routine maintenance. And then failing to make restorative repairs or failing to make them in time bumps the asset condition over a threshold where it can't be restored and needs to be reconstructed to function. And this costs up to 10 times more than maintaining the asset. And it puts you right back at a new opportunity to maintain it routinely, or try again to dodge municipal enforcers and let it fail and rebuild. And then, of course, these poor conditions degrade the user experience, lowers the property value, and just keeps putting Class A property standards farther and farther out of reach. I know you can't read this, but we'll talk about how you can get your hands on it. Our engineer has developed condition score criteria for various types of SEMs, structure, function, and contaminant load, to frame the maintenance needs of the assets. The condition score criteria is actually something we love to share and get feedback on. It always makes for interesting conversation about different ways that people are organizing this complicated information. So please reach out if you want to see the whole thing. We have criteria for PICPs, EDBs, bioretention, storm, sewer, and underground SEM. The condition scores overlap with our framing of maintenance costs. So we can speak to the operator's concern, which is cost, but also the enforcer's concern, which is structure, function, and contaminant load of the SEM. And we talk about the levels of service consistently to reduce confusion. Routine maintenance when the asset is newer or restored and in good condition and compliant with municipal code and least expensive to maintain. Restorative maintenance when the asset is not compliant with municipal code and needs more extensive, more expensive service to bring it into compliance. And reconstruction when restoration can't bring the asset into compliance and you'd just be throwing your money away to keep trying. So for this first case study, we're looking at permeable interlocking concrete pavers and comparing two client profiles. Here's the timeline. Both are notified by municipal enforcers that their pavers are non-compliant. They both get restoration service. We'll talk about what that entails. Client A pavers are then compliant and they have a chance to get on a routine maintenance schedule and stay compliant. But client B pavers still fail the infiltration test, which we'll talk about that too, and need to be constructed. They're too far gone. So client A initially failed the test and was not compliant, but was not far off. The pavers weren't in horrible condition. They were more newly in need of restoration. And after restoration, the asset was in great shape, passed the test easily, and can be kept compliant with the least expensive service, routine maintenance. Client B, on the other hand, failed the test badly. The pavers were in bad shape from years of deferred maintenance. The client had to try restoration, and it did improve the condition, but that 5-figure expense ended up being a waste for them because we couldn't bring the pavers back, and we'll dig into why. To understand the levels of maintenance, let's look at the paver system itself and the gallon pour test, which informs the condition score.
Permeable paving allows water to pass through into the gravel layers. It uses unique products with grids or patterns filled with gravel or grass. These robust and durable products can withstand heavy loads and traffic while also maintaining permeability. A simple test for the functionality of the paver system is to pour a gallon of water over the surface at an even rate. The distance the gallon of water travels directly reflects how well the paver system is capturing water as opposed to letting the water run off.
The infiltration test is from the Colorado Stormwater Center Permanent Water Quality BMP Inspection and Maintenance Field Guide. Now, all of the maintenance that we can really do is at the top brick layer. We can remove materials off the top of the joint rock between the bricks, which is routine maintenance, or we can completely remove the joint material, vacuum removal, and replace it with clean rock. Everything below that, in cases where the sediment and grime has worked its way through lack of maintenance down into layers below the brick, is a reconstruction situation. Once you're pulling up brick, you're in the very expensive reconstruction zone. So the very different outcomes in the two cases was due to the starting condition and the amount of time the asset was in use without maintenance. With the better beginning condition score, we could do the restoration and improve the condition into a zone where all that was needed to keep it going for a while is routine maintenance. And this is what that looks like.
Lawn and litter vacuum with 1700 CFM suction. This removes grime and debris off the top of the rocks without removing the rocks themselves. Removing sand, dirt, Leaf litter and the grime that sticks to it allows the system to function properly for longer. Clean joints mean grime is not working its way deeper into the system. How often this type of maintenance is needed is site dependent. We recommend starting with twice per year and adjusting based on inspection results.
Now let's look at what restoration when the asset is not compliant looks like.
In the Cabot court case, the water was running 12 feet downslope before maintenance had begun. To update the paver system, first SRS removed all the old gravel using a high-powered vacuum system. Water is used to break up the sediment to allow the soiled aggregate to be removed with the vacuum. Any small weeds or grass are also removed to allow fresh gravel to be inserted. Finally, the paver blocks are refreshed with new gravel, specifically washed number 89 aggregate. The new gravel is carefully swept into all the gaps between the paver blocks at an even and consistent fill. Once maintenance is complete, the permeable pavers are tested again to check how far the water spreads. After maintenance, the paver system at Cabot Court had improved to a spread measurement of less than 2 feet, an 84% improvement in function compared to before maintenance was done.
So in the client B scenario, after they had attempted to restore, which improved the condition but nowhere near enough to bring it into compliance, they're left with no choice but to reconstruct the pavers. This kind of too late to do anything zone is where the real expense comes in. The city of Boulder, Colorado has researched maintenance outcomes and costs on their own pavers and published Pearl Parkway permeable pavement maintenance trial results, which cites routine maintenance at 50 cents to $1 per square foot, restoration at a cost of $3 to $4 per square foot, and I'll say we've seen this service below $1 a square foot, and reconstruction at $8 to $10 per square foot. So these two paver clients are on very different timelines and putting out for very different expenditures. Client A caught the need for maintenance early. The enforcer actually caught it, but the client took action to quickly restore it, and they'll be compliant and in that routine maintenance zone for potentially years before needing restoration again. While client B wasted money on the restoration attempt, although you couldn't blame them for trying, because the alternative is to rebuild, and then what? Back to deferring maintenance and dodging enforcers until the asset fails again, or starting the routine maintenance, the very expense they were trying to avoid, right after completing the big construction project of rebuilding the whole thing. And the cost of the different timelines is so different. If we use an example site, since the two real sites are different sizes, and apply Boulder's numbers, the cost of these service levels are drastically different. So that's the end of the paver case study. Next up is detention pond. Jason, is this a good time for questions?
Sure. Yeah, if there's any questions on the first case study. Yeah, otherwise, please just add it to the chat and I'll try to address it when I see it.
Fantastic.
Go ahead, Emily.
Thank you. Okay. So this next case study is about an extended detention basin perpetually living in that restoration zone due to it being under-designed for the conditions. The pond was needing restoration 2 times per year. They were spending nearly $17,000 a year trying to occasionally be compliant, but really were always remaining behind the 8 ball. And because the amount of material entering the pond was sometimes keeping pace with the amount we could remove during restoration, the pond was never cleared. The best we could do within their budget was to just keep it from getting worse and let them know in the quote that it was likely that the existing sediment within the pond would resuspend each year, causing clogging issues until and if restoration was complete. Now let's look at 3 snapshots in time and how it became clear to us that at this rate, restoration would never be complete.
Let's look at 3 aerials of the Ziegler Pond from Google Earth. One from June of 21, right before our first clean out. One from April of this year after 3 cleanouts, right before our 4th. And one from just a month later, right after our 4th cleanout in a super wet year. The sediment is drier and lighter in the first picture, but you can still see that it fills the channel all the way back to the northwest inflow location of the Ziegler Pond, and the long center channel is full or patchy at best for the full length. Fast forward 2 years and 3 cleanings, and the channels are definitely more clear, but just 2 weeks after a cleaning on a very wet year, the channels are filling back up.
Our engineer determined the amount of sediment coming into the ponds off the more than 2 million square feet of pavement on the property was overwhelming a few design and installation flaws on the system. We came to realize the pond would never be able to manage the load without permanent improvements. Now, the reason investing in the improvements and finally achieving full restoration might matter to a client is that it could lower the long-term maintenance expense to be doing routine maintenance on a finally fully functional system. So we really had 3 options. First, we could stay the course and probably expect ongoing restorative maintenance costs to be a permanent line item in the budget and likely manage some occasional violations from the city. Or reach full restoration of the pond and potentially lower the cost of the maintenance in the long run, which we thought would require pond improvements and a source control audit. So let's look at those 2 options. Here's what we envisioned for the pond improvements.
As it is, the outlet structures were not constructed with trash racks in front of the well screen, like this one, for example. So the well screen is constantly clogging and requiring chicken wire workarounds. Retrofitting the outlet structure with wing walls and a trash rack would meet design standards and improve operations of the pond. This is the most simple, cost-effective, but still compliant design that would improve operations of the pond. Additionally, 2 of the Ziegler Pond inflow locations see significant amounts of sediment, and adding 4 bays would improve operations and make the system easier to clean. 4 bays slow down the water as it enters, allowing the sediment to fall out in a consolidated, easy to maintain location, and releases the water slowly down toward the outlet, arriving much cleaner and less likely to fill the trickle channel and clog the outlet structure.
And since we thought the amount of sediment coming into the ponds may still exceed what the pond can handle, even with the improvements, we argued that they could prevent some of the sediment from entering the ponds in the first place with a source control audit and a few strategic tweaks to contracts they were already managing.
The audit would identify parking lot sweeping, snow removal, and landscaping adjustments that would avoid costly mistakes and optimize the impact those services have on your storm drainage system.
Laying out these options and offering a stack of services allowed us to work within their budget while continuing to keep inching the property into that routine maintenance zone so they could spend less per service. So that is the end of the detention pond case study. Is there anything we should discuss from the chat, Jason? Or if you have a question, you can unmute and...
Lee, I have a question. This is John Tarascus. Your source study, what were you identifying as the main source of sediment?
We identified a couple of different sources. One was the sweeping operations were not done correctly. They weren't being managed correctly, and a lot of the sweeping material ended up in the storm sewer because of the specific contractor that was, his process. So that was one. Another one was landscaping and how they were managing the turf and other vegetation around these ponds, whether or not they're just cutting it, leaving it in the area, or cutting it and collecting it, things like that, where they were storing their ice melt material, where they were storing snow piles, and how to manage those things. All those things kind of added, um, identified benefits on how we could reduce the sediment in the system.
And I would say there'd be an additional benefit. You're getting that much erosion from your landscaping. That's going to be another maintenance item of a different nature, replenishing the topsoil you're losing.
Well, and grass clippings.
Yeah.
There's a grass clippings in the pond situation.
There's a question in the chat that says, what was the flow bay design called for the sediment reduction? Your illustration was cool.
Yeah. Oh, good. Forebay. I don't know, Jason.
It's a four bay. It's a four bay design, which basically is a containment area that's sized specifically for the inflow. It's not intended to manage large flow events. Basically, large flow events will blow right by it. But for smaller storm events, the wall in front of the outlet would slow and dissipate the energy, allow sediment to fall out, and then re-release through the notch down to the outlet structure.
Oh, there's not a good slide for it.
No, it's the one that, the animation. So I don't think that one's good. But yeah, it's
that little, like, is it like a T, the energy?
Yeah, that's a baffle wall.
Yeah.
And again, that the whole purpose of that, and I see a lot of forebays that don't have that, is to stop the energy so the larger storm events don't just blow out the sediment that's already in there. You can really do a lot of benefit just by slowing the energy down, even under large storms, from whatever sediment was trapped and being stored in there isn't going to end up in your pond or in your outlet by just slowing it down.
Excellent.
Okay.
Anything else in the chat?
No, that'll do.
Okay. And we actually talk about source audit again in this next case study. For this third case study, we're looking at the value of designing with long-term stormwater system operation and maintenance in mind, and the value of considering stormwater systems in all the projects you do on your property so you aren't breaking things or blocking access, and the value of inspecting stormwater systems early before taking possession of them, early enough that they are still compliant, or better yet, early enough that they're still under warranty, all with the goal of keeping or moving the property into that routine maintenance zone, which is least expensive. The first profile is a non-standard MS4 client, and the context is construction swamp inspection with an eye toward the long-term operation and maintenance of the drainage system. Jason identified there was a drop from the concrete pan of a detention pond to the adjacent grade, preventing runoff from getting into the pan, which is where it would be most easily removed. And a conveyance channel missing surface treatment altogether, making sediment removal really difficult. This next client profile has underground SEM with 6 isolator rows. And in this case, the operators of the property got good information about their assets at handoff and called us in early to understand their system's maintenance needs. They were smart to learn about their asset because it's so valuable at that brand spanking new end of the condition scale. They had an opportunity to do a lot of prevention. We recommended an inspection of all the rows right off the bat, well before they were expected to need maintenance, while the system was under warranty, to check for access problems. And in that initial inspection, we found that 5 of the 6 inspection ports were inaccessible. 1 with the valve box blocking access to the port, 1 with crushed housing preventing access to the port lid, 1 with the port filled with mud, 1 with the housing lid painted over, prohibiting access to the fasteners, and 1 with the housing lid asphalted over. So in this case, because of those early inspections, the client got the information they needed to have their pavement contractor correct all of those problems. And then this client profile is a developer surrounded by development on a jurisdictional boundary. And the lesson is about mapping the source of sediment to prevent SCM clogging as much as possible. The client's detention pond is here in blue. And one source of sediment is from the undeveloped lot located along Private Drive A. The lot is generally sloped from south to north. The arrow is pointing the wrong direction. That's confusing. From south to north with no obvious drainage path. The section of the curb right here is broken, allowing runoff to enter the drive and drain across the street to an inlet. A storm sewer pipe was stubbed into the lot and terminated at a manhole with a solid lid that prevents water from entering the storm sewer. And this is the manhole with the solid lid right here and the stubbed in storm sewer. So there was no way for water to get in here. The broken curb was the only path for runoff to exit the lot. And since it isn't draining as designed, it's carrying sand and sediment from the lot to the storm sewer and ends up in the southern forebay of the client's pond. Another source of sediment was from this King Soopers detention pond across a major parkway. The inflow pipe into the water quality chamber of the outlet structure on the pond was mostly blocked, and the well screen protecting the water quality plate was clogged. The pond discharges under the parkway and into the storm sewer, contributing to the client's pond, and it's in another jurisdiction. So we worked with the neighboring jurisdiction to get that resolved, but that required us knowing in the first place and understanding the source of the sediment coming into the client's pond. This audit helped to serve the client's goal of minimizing two things: expensive restoration and notices of deficiency from the city, by preventing problems from coming onto the site wherever we could. So that case study is about designing and considering stormwater operations with every project and inspecting quickly. Anything in the chat to discuss, Jason, or does anybody have a question they want to unmute and pose?
No, I don't see any chats or questions in the chat.
Okay. Interrupt me if you have a question. I will keep moving in the meantime. So in this last case study, the client has their horizontal assets, those pavements, ponds, and pipes outside the building, mapped. They have inspection and maintenance information associated with the shape files in the map, so they can easily access information for municipal inspectors, and their assets are maintained regularly to keep them in compliance. They're really investing in staying in that routine maintenance zone to reduce their expenses and long-term costs. And they are invested in the time and money saving practice of organizing information about their assets. They have easy access to utility plans and drainage plans, standard operating procedures from the development agreement, site photos, reports from biannual maintenance. The biannual maintenance reports include functionality testing results, observations, photos, and that important condition score. The condition scores for each of the site's assets are compiled into maintenance indicators on the site dashboard. Maintenance indicators allow for an understanding of which assets need restoration for budgeting and planning purposes. Here's a quick video we use to train clients on how to use the dashboard and the information in it to budget, save time, and prioritize the work.
Accessing your site dashboard is as easy as clicking a link and viewing records for each individual inspection or maintenance visit on your site. Clicking on a record will open a dashboard for that record. You'll see a map of your site with the stormwater infrastructure indicated and a legend on the right. You'll find easy access to relevant resources, like a link to your development agreement with the city, which spells out your responsibility for the stormwater infrastructure on your site, and construction plans, which offer specifics about how the infrastructure is meant to function. You can toggle back to the previous record and forward to the next. When it's time to budget, you can easily see which assets fall below your routine subscription level and need to be restored. Restoring infrastructure, while it still can be restored, keeps it out of this red zone where the system can't be restored and needs to be completely reconstructed.
That is all I have. We would love to be in touch, especially around the language that people are using to educate clients, but also have it make sense with the enforcers. That's been really educational for us to see how other people are talking about this stuff. And we have plenty of time for questions if there are any.
Yeah, John's question regarding do we find that the owners of these assets, especially low impact development assets, are well informed by the original design team for the required maintenance and life expectancy? And the answer is no. It's really, we're seeing a huge disconnect from the time where the developer is involved with the property and, you know, going through entitlements and design and even through construction, to when the developer hands over the property to the end user, whether or not it be the owner, the association, the management company, whatever it is, that is a huge disconnect. And when we talk to municipalities and we talk to clients, we just see that there's just a lack of information being passed at that point, and that is really critical because that includes all of your budgeting and all your understanding of what you're required to do going forward. I would say I talked to 10 clients. I would say less than 4 know that they have assets that need maintenance. It's not until they get a violation or flooding issue or something else that those other clients end up coming to us and, you know, having the conversation about what they need done. So that's a big issue that we're trying to address, and, you know, working with this similar, trying to the communication and how to get this in front of people. This is really where we're trying to inform people and how to connect those dots. I'd love to hear from anybody if they have an easier system or some kind of something written in the municipal code that could help that process be better, because right now I think a lot of municipalities are struggling with how to do that.
Yeah, thanks, Jason. Maybe this is a regional issue. I don't know. And perhaps we can hear from some of our viewers today. I know we help entities on both sides of the fence. We help engineering and design teams with their low impact development features and conceptual modules, or models, I should say. But we also do plan check reviews for a handful of municipalities. And what I'm seeing is many times that does not get communicated to them. For example, if you purchase a roof, you know, a new roof, they're going to tell you the life expectancy of that material. You know, is this going to be a 30-year roof or a 50-year roof or whatnot? And we're finding that with these types of features, either the design team doesn't know, which may be the case, or it's just not getting communicated that saying, okay, you have these choices: pervious, bioretention, pervious pavement, a retention pond. Here's the life expectancy, here's the maintenance costs. And so that before it's built, they can make a informed decision as far as which route they go, especially with the down the road dollars you're talking about.
Yeah, John, that's a great point. And I can tell you, as coming from the design side, I was a design engineer for 20 years, designing stormwater infrastructure for development. I did the same thing. And I'll tell you, in the last 4 years that I've been working on maintaining it and figuring out how to maintain it, if I would have known then what I know now, I would have designed things very differently. I would have, tried to set up different systems based on the long-term maintenance costs. So it's actually quite difficult uh, for that knowledge to be out there at this point because a lot of these assets just haven't been in operation. So there hasn't been a lot of people maintaining them. And without people maintaining them and knowing what their life cycle expectancy is, what the cost, what the resources, how to do it, without all of that being established when the designer's putting that in the ground or putting it on the plan to have it be put on the ground, there's just a big disconnect. I think as a designer, my priority was to meet the jurisdictional requirements and, get it approved. And however that, get it approved for the least amount of cost possible for the
Right.
developer.
Now
And
in California, we have in our permits, our MS4 permits, written the requirement to have an O&M plan with
Mhm.
a long-term maintenance plan as well. In fact, either under the construction general permit or under the MS4 permits, that's required. But really, the onus of the implementation of that is dumped onto the municipalities' shoulders. And
Mhm.
different municipalities have, are more proactive than others, probably because of resources. But we're finding that even though there's plans there, oftentimes these devices are left in place without anyone even maintaining them, or especially as the property sells and goes to the next one, they might not even know it exists. So I'd be really curious. We got viewers on this from all over the nation. I'd really be like to hear if there's some success stories, and even from you and Holly, if you've seen how that's being handled.
Yeah, I
Yeah,
joked
no.
that our company slogan should be delivering bad news since 2021 because we usually are not able to tell people what they want to hear. And there's a lot of energy on our part going into trying to use really simple language and use really consistent language and use language that the client relates to, but also that the enforcer needs, so that we're just clawing our way to an understanding, on a really steep learning curve of people realizing that they have these assets, they need to be maintained, and the risk, to have underground SCM on your property is potentially a low long-term maintenance expense, but a really high risk if you just put it underground and forget it. So knowing what you've got in place to get your system organized and make sure that there's an eye kept on it, is really high importance and low awareness.
Yeah, we have a comment from Jason Kaufman, City of Goshen. Jason, you want to unmute? I'd love to hear your perspective on this. Don't mean to put you on the spot.
No, no worries about that. I commented. So we do have we've been requiring for maintenance agreements for the full post construction, which includes a maintenance agreement, to be recorded via the county recorder's office. And we receive these documents and routinely have to remind the designer that this is an O&M manual for the property owner and future property owners, hoping that it's written in such a way that the property owner will understand it. Where we're running into trouble is the education, the fact that the property owners don't actually understand this document, they don't see the document, and so then maintenance is deferred until it's needs to be fully replaced.
Yeah, Jason, that's a really great point. Where is the city of Goshen? What state?
City of Goshen, Northern Indiana.
Northern Indiana. Thank you. Yeah, it's funny. You've got a step further than I've seen here, at least in Colorado. We're getting it into the title documents, which is awesome. But again, like you indicate, there's just lack of translation for that next property owner, property user, manager to understand what that means. I mean, I got to tell you, as an engineer, I describe things very differently than what a property manager would want to understand. So there's a lot of translation that needs to go on to know exactly what that means. And I, I've often thought that engineers need a class just in how to translate our jargon so that it's not so um,
Or a
it's
whisperer.
or somebody
Yes.
like that. Very good. But
But
the one thing that I've seen that I think works is a couple of municipalities here in Colorado along the Front Range are requiring owners to be proactive, which basically means they're requiring a yearly maintenance verification that clearly states that somebody or they looked at their site, looked at the infrastructure, and deemed it fine or needing of maintenance, or maintenance was done or something like that. So the annual onus is on the owner rather than the municipality trying to keep on top of troubled site or difficult sites. And it just redirects the who's proactive. So I think it's a good policy, and I kind of want to see how it turns out going forward. There's a lot of administrative work associated with that from the municipal standpoint. They have to review all of these documents. They have to document. They have to confirm that it was done, and chase after the ones that aren't. But at least I think with that change, where it's the onus is on the property owner, it's just different. Then they know they need to be educated about what this is. They know they need to do something in order to get this document sent in on an annual basis. So it's
Yeah.
one I've seen that's positive.
The California Phase 2 MS4 permit requires municipalities under that permit to send out an annual self-certification letter or postcard to the owners of these, asking three questions basically. One, does that device still exist? Did you rip out your bioretention cell to put in your RV parking? Two, are you staying up on the maintenance? And three, is it still effective? Is it still like your the video you showed, pouring the water on it, does it spread 20 feet rather than 2 feet?
Yep.
So is it still effective? Now, those go out, you got to imagine there's a lot of pencil whipping. If you got a postcard like that in the mail, what would you do? Yes, 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 right?
Yeah, that's it.
What kind of, in fact, I know we got some phase 2 MS4s. I've seen them in the participant list here. What kind of verifications happening by municipalities? Maybe either that Holly, you and Jason have seen, or we got some MS4s here. How are you verifying that they're staying on the maintenance? Or is it just if it starts flooding and it's part of a root cause investigation? What's going on out there?
It varies a lot from municipality to municipality, except that the consistency seems to be that they're pretty overwhelmed. The amount of staff to do the stormwater enforcement job is usually not enough. Follow-up is, they're doing the best they can. So from one place to another, it really depends. And certainly when the municipal staff is overwhelmed, some stuff is going to fall through the cracks. So there are some players that just, have an asset that just over and over again, it's kind of just sitting there failing. That I think that's the pain of being at this point of the learning curve. We do in Fort Collins, which is where we live and have several clients. It's in the development agreement. The development agreement includes a standard operating procedure for maintaining the LIDs, all of the stormwater infrastructure. And the end user has not read the development agreement 9 times out of 10, but it does help because it kind of all stacks. Like the enforcer will get there and say, this is a problem, this is on your property, this has a stormwater function, you need to understand it and maintain it. And then they'll have this notice of deficiency from the city and start looking around and talking to people and vendors to figure out how to do the work. And then we try to reinforce the same thing that the city has said, and we have a habit of finding their development agreement for them. And it helps that it's there. It helps overcome the obstacle for them of understanding whether or not it's their responsibility, because the first question is there any way this can be somebody else's problem? And how much is it going to cost if it has to be my problem? So having it in the development agreement or anywhere that is logged with the county clerk, that does help get over that obstacle faster. And using the same language, being kind of aligned in the importance of it with the enforcer helps. And some municipalities are doing on-site inspections every 5 years. They're getting to the same site. So it's kind of on a rotation. Some municipalities, like Jason said, are proactively requiring something from the property owner. And as you can imagine, doing a ton of follow-up. That's not a set it and forget it program.
Okay, we had a comment kind of to this. Amber says, in our area, we send out a fact sheet and a maintenance checklist for each type of LID, and the owner has to return a signed certification letter. We are trying to educate them as we ask them to perform maintenance and self-certification. And then another, Sue mentions, our challenge has been receiving any response from the private landowners. I can imagine. You get this thing in the mail, it's like, what is this? Regarding their annual BMP inspections, we had a little bit of response this year by creating an online survey. Yeah, I think, you certainly get a certain percentage who's just going to throw it out. You got probably the majority who don't understand what you're even asking about. And then you probably have a small minority who understands what it's about.
I'm really curious to know about that process of the fact sheet and the checklist. That's brilliant. Where in municipal, is that in municipal code? Where in the process? When, who is it? Is it the end user? Who is responsible for that change off, and how is it enforced?
Yeah. Very good. We got a lot of municipalities on. We'd love to hear from you. We still got a few minutes. What's been your experience with tracking down the performance of your low impact development or your green infrastructure out there? How do you know you even have an issue? And do you want to commiserate on, is this an unfunded mandate? By the way, who gave us this responsibility to go out and inspect these? We hear a lot of that. It's like the cities, municipalities have very little, resources to spend, and this is just one more thing they got to do. Anybody want to chime in? If not, Holly, while maybe we're waiting, throw up your contact information slide, maybe, just so people can call you. Now, you're in Colorado. What geographic areas do you actually service?
We have clients, mostly Front Range of Colorado clients, all the way down to south as far as Parker, which is south of Denver. Fort Collins is about 60 minutes north of Denver. And that's about as far north as we have clients. A lot of the municipalities along the Front Range are, they're passing the LID municipal code, or have it passed for several years and are at a place where the assets are starting to need maintenance.
Right.
And my email address is here for anyone who's listening and not watching. It's holly@sustainablerunoff.com. That's also our website, sustainablerunoff.com, so you can find us there. And, we're always trying to provide quick, impeccable service. So should not be hard to get a hold of us.
Right, and you got to check out their website, especially the about. If you want to see Holly and Jason in a new light, you got to check out their about page on their website. So, all right, well, any last questions from anybody? Otherwise, we'll let you get to the next workshop. We do appreciate you being with us for this workshop. Any last comments? I do got one here. We are a SWIP inspection firm in Northern California. And the way our regional board is handling that is they will not allow a notice of termination to be finalized until the owner submits their LID documents. So they now have it on record, and now the owner knows what are their responsibilities. Yes, that's through the CGP. They're doing that. The thing is, though, what happens 5 years down the road, 10 years down the road? And that's what we're talking about, is after it's sold 2 or 3 times. Sometimes it can be really hard to stay on top of that. But thank you for that comment. All right, well, Holly and Jason, thank you. This has been wonderful. And we're going to upload a PDF copy of your notes onto our resource page. And to everyone else, thank you for attending this workshop. We have lots of other good ones coming, so we'll see you at another workshop this week.
Thanks so much.